I put together full courses in subjects in science, technology, engineering and mathematics. So I start from really basic mathematics and I work my way through to some quite advanced stuff. Now here's one of the courses I've got on at the moment, and it's called Design and Simulate an 8-bit CPU. So if you think you might be interested in that, you can click on the link below and it'll take you through to the blog, which is on my website. Now in this course I go through the complete simulation and design and simulation of a fully functioning 8-bit CPU. So if you click on the blog, you'll take you through to the start of the blog here. Now the first part of the blog, I've got a little cameo of the course, so you can click on that and play it. So I'll play a little bit of that just now. So that gives you an idea of what the course is going to be like. You're going to be actually designing and simulating the CPU in a software tool called Logisim, so you can build it up completely from Logisim and you can see it working there in front of you. And I go through and I describe the entire simulation, the entire design. So, but first of all in the blog, I'm going to start off with a bit about how a computer works and what a computer is. And we're going to go through a little bit of a philosophical start when we look at the ideas of geological time, human time and computer time. And it gives a good introduction and it lets you know the power of a computer and what it means in order whenever you are able to do billions of things a second. What exactly is that going to do for you? How is that going to be of use? How is it going to change the world? Now I think we all kind of grasp how that changes the world because we've seen it and we're witnessing it right now. So after that I go and I start back looking at the main building blocks of the computer. So I'm going to start off looking at the registers and I describe exactly how we're going to go through the design of a register. And then we go on and we look at the actual architecture of the CPU, and this is the architecture here. So we're going to have a control unit, a RAM, a memory address register, we're going to have 4 registers, and we're going to have an ALU and a clock, an accumulator and a few other sundry items that I haven't actually drawn in here, but I will go through in the rest of the blog. So we talk through the RAM and we describe how the RAM is going to be made and exactly what it does, and then the accumulator and the temporary register and the ALU, and then we go ahead and create a little pseudo program that will allow us to just do a simple task. We then go on and we look at the clock and how we are able to pass information from one part of the CPU to another using the different clock signals. And then we go on to the most interesting part of it, which is the control unit. So this is really the beating heart of our CPU, and it controls the flow of information all the way around the CPU. And in the process of controlling that flow of information, that's how we generate our machine code, and from our machine code we generate an assembly language. So this is one of the instructions here which are actually hardwired, and it gives an indication of how the control unit works. We then go on and we have a look at the actual assembly language and we build up our first lot of instructions. So here's our first instruction here, which is an ALU instruction. So it allows us to do addition, a shift right, shift left, not, and, or, exclusive or, and a compare. There are other assembly language instructions which we'll get on to just in a second. So we build up the entire assembly language, and this is our assembly language code here. So these are our instructions, this is roughly what it does, and here's the actual instruction. So if you take one of them in particular, we're going to have a clear flag instruction, and we have our jump instruction, and these are all our jumps, and we've got input output instructions as well. So this is our entire assembly language, which you will actually design yourself, and you'll hardwire this assembly language into the control unit. Now here's 3 programs which I've written. So this one does a divides 2 numbers, this subtracts 2 numbers, and this creates the Fibonacci series. So you'll be able to actually put this code into the actual CPU when it's built, and you'll see it actually running, and you'll see it doing the division, the subtraction and the Fibonacci numbers. We then go on and we look at the idea of a debugger, and we simulate the whole of the CPU within Excel using Excel VBA, and we build up a debugger. So in effect what we do is we take the CPU which we've got designed in Logisim, and we create an equivalence of it in Excel VBA. So this allows us to run the CPU really quickly in VBA, so it allows us to create our assembly language code and test our code very quickly in VBA. And if it works in this Excel VBA spreadsheet, then it should work on the CPU. And here's the actual final CPU. So we have our control section here, we have our RAM, our memory address register, we have our 4 registers here, we have an ALU, we have a flag section, we have an accumulator temp register, and we've got an instruction address register, an instruction register, and we've got a few other little sundry items here that I had to add in order to get it functioning properly. So in the course we'll actually go through and we'll build up the ALU, so that's the ALU there. We'll also build up a 256 byte RAM, this is it here. And here's an actual final control unit which we'll design. Now don't worry about it, it looks complicated, but we break it down into little sections and we work through each of the sections, and you get to understand exactly how the control unit works. And this is really the beating heart of the CPU, and from this design, this in effect is a hardwired design which allows us to define our machine code, and from our machine code it allows us to define our assembly language. So finally, at the very top level, you have to have an input and output. You have to be able to see exactly what's happening in the CPU. So we have the CPU here, and we have an external RAM. So in effect this is where we load up the CPU with our program. We've got a few control bits here we use to control the CPU, and then we have the output from each of the registers, including the instruction register, the instruction address register, the accumulator, and also the information that's on the bus. So from this we're able to see exactly how the CPU works, and we're able to check and see whether it is actually giving us the correct answers. Now, if this all looks quite interesting and you enjoy the blog, you can sign up for the course. So all you need to do is click on one of the buttons. So here's a sign up button, so you can sign up for the course here, or you can go up and you can click on to the all courses section, which is up at the top here. If you click on the all courses, it'll actually take you through to all the courses which I have available on my site at the moment. So I've got the design of CPU, so you can click through to that if you're interested. And this takes you through to the CPU design course, and you can enroll in the course. So if you click on enroll, now I've got 2 people so far as of today who have enrolled. The course costs $10, so you can pay by your credit card or you can pay by PayPal. Now the site's built up on a site called the website's built up and it's hosted on a platform called Teachable, which is there in order to provide online educators like myself a platform in order to build their courses. So the courses and the payment system is all absolutely safe and secure, and I've already got 2 people paid for the courses at the moment. Now all of my courses in fact are also available on Udemy, which is an online learning platform. So that's everything from me. I hope that I've not emmed and ammed too much and you can understand my accent, because yeah, that's right, it's a Scottish accent. I'm that used to listening to my own accent, I just assume that everyone else must talk with the same accent that I talk with. Anyway, thank you for listening to this video. There's a load of other videos on the website and the YouTube channel here, so if you click on the YouTube channel, it gives you an indication of all of the stuff that's on my courses, and if you like any of it, then you can click down below and it'll take you through to my website. And if you are interested, you can go through and look at some of my blogs. I'm putting more and more blogs on all the time, and if you like the blogs and the courses look good, then I would be happy if you would go and buy a course, because you buy a course, it allows me to earn some money so as I can create more and more courses. So thank you, and I'll get you in the next video. Goodbye.